Is Ivana Nekic, and today I will talk about the light. Light is a wave and sound wave. 100 years ago, there was a great debate between physicians about the nature of the light. The main dilemma was discussed if the light is a wave in his origin or it is just a bunch of particles, which I believe Isaac Newton. The truth is neither is totally correct, and the light has both futures, some of the wave behaviors and some futures of the moving particles, depending on the conditions of the light. When we focus the light through the window, like ornament crunches window, the light we will pass through and we will form the authentic ornament shape on the back wall, just like the window. If we spray with a high pressure color through the same shape, we will get the same picture. That could indicate and support the theory that the light is a particle origin. Anyway, that is not true, because the light have a wave characteristics and can be seen only in special conditions when the light passes over the small project, and the background picture won't form the proper same shape of the object, and instead it will appear a combination of the light and shadows. This phenomenon calls diffraction, and it is a result of the interference of the light waves. Diffraction is the ability of the light to form a pattern of the bright and shaded effects in the back when the light rays deviate in a content with a very small obstacle with same or similar size as the light wavelength. The backward picture consists the bright zones, which are a summary of two waves with the same phase, and the dark zones represents the cancellation of the wave. Diffraction of the light can be compared with the sound propagation ability, where we can hear the sound behind the obstacle, but only the length of the light wave is microscopically small, so can affect the micro objects to be seen anywhere. The diffraction feature is applicable to the single obstacle, and interference is the following continue of the same effects, but when it is involved two or more objects. The physician Huygens has explained the motion of the behavior of the light when the light spreads in the space. The wavefront consists of many points who act as a new secondary spherical source which advance forward with the speed of frequency like the primary wave. As we have mentioned before, some features of the light and some can be compared to the understanding their wave natures. The main differences between the sound and light are that the sound needs the medium surface, light doesn't. The sound waves are longitudinal and the light have the transversal wave. Anyway, the model of the two sound speakers positioned one by one can help with the better understanding of the interference features of the same harmonized wave came from different sources. The results of the interference can be constructive interference when the two waves meet each other in phase and assign peaks of their amplitude summarize, and the results wave will become doubled interference maxima. Another situation is destructive interference, where two waves meet each other with the opposite direction and the same amplitude. They cancel each other, and the result is interference minimum. The interference results depends of the distance difference between two initial waves. Constructive interference must satisfy the condition that distance difference corresponding to multiple of the same wavelength, delta d is equal and lambda, until destructive interference can be so two waves needs to satisfy distance conditions that delta d is equal to n plus 1 multiple lambda over 2, where n can be from 0 to infinity. Thomas Young has first empirically presented the wave nature of the light with a double slit experiment. It explains the best the interference behavior of coherent light, the light with the harmonized oscillations of electric and magnetic field, the same wavelength, the same direction, and the same phase differences. The coherent light from the single source is passed through the small slit, and by following the nature of the light, those slits become the new light source with the same future as the original wave. As a result, the brightest zone was the center of the screen. As the result is the wave superposition is the maximum at this point. The second important condition besides the coherent wave is the condition of the environment. For the proper interference, the environment must be homogeneous, same future is at all points, and isotopic, same condition in all directions. In nature exists polychrome light consisted of many frequencies, many colors, and a monochromic light, one frequency and one color, such as a laser light, which can be used the best today for Young's experiment. In his time, he guided the visible part of the spectrum from the most complex white to the edge of the wavelength of the red and violet, which can be numbered from 350 to 750 nanometers. Finally, on the end, we can say that the light is an electromagnetic transversal wave where electric field oscillates perpendicular to the magnetic field, and both fields oscillates perpendicular to the light propagation direction. For more complex 2D and 3D, can be used a plane combination of straight and dashed line. That would be all. Thank you for watching.
Hello everyone, my name is Alex and I'm going to be your host for this part of the presentation. We're going to discuss about Thomas-Young experiment and the single-slit diffraction. We already learned that light is an electromagnetic wave formed by oscillation of electric and magnetic fields. Before we talk about the single-slit research performed by the famous scientist Thomas Young, I just wanted to discuss briefly regarding the double-slit experiment. An experiment of using a beam of light passing through a double slit was made, and the scientists initially thought the light would produce a single spot of brightness. However, when this experiment was performed, the result was that multiple bright spots were produced. They discovered that when the light passes through a double slit, the light does not produce uniform brightness. Instead, it produces an alternating of bright and dark between multiple spots. It is known as the diffraction model. This model is created when the wavelights interference with each other, creating a constructive or destructive interference. After this little intro, we can talk about how the single-slit diffraction works. Likewise, light shone through a single slit also have a diffraction model. This means the brightness of the light alternate between bright and dark spots. There are two major differences between a single slit and a double slit that I'm going to point out. The first major difference is the central bright spot. For double slit, the thickness of each spot is the same as the other, but for a single slit, a central bright spot is twice as wide of the other bright spots, meaning bigger. So this model can be observed only for the central spot. All the other spots will have a uniform size. Like in a double slit, the diffraction model is produced due to the interference. The second major difference between a single slit and a double slit is that for double slit, you have two sources of light interfering with each other. And for a single slit, you have just one source of light. This means that the light leaving from the top of the slit and the light leaving from the bottom of the slit does not have the same angle. When the light waves arrive on the screen in phase, these waves you have peaks. When both waves have peaks, it will produce a constructive interference or a bright spot. The amplitude of the light wave increases under constructive interference, so higher wave amplitude produces brighter spots. When the light wave arrives on the screen out of phase, The waves you have a peak and a trough. When this situation happens, a destructive interference or a dark spot is created. The amplitude of the light wave decreases under destructive interference, so lower wave amplitude produces darker spots. Light spots are actually called fringes. For single slit problems, we have just one equation that gives us the location of these dark fringes. The equation is defined as sine of theta is equal to m lambda divided by d, where m is the index number for different angles, and d is the distance between the top and the bottom slit. Well, this covered the discussion about Young's experiment and the single slit diffraction. The next host will be continuing with this presentation. Thank you.